Before we begin, take a moment to get comfortable. Let your arms go heavy, your breath slow. And as you listen, feel free to leave a comment sharing what time it is, where you are, and what city or village you're listening from. It's love to know. And if you'd like more quiet stories like this one, don't forget to subscribe so they gently appear when you need them most. Now, let's breathe in, let it be soft, without force. Not an effort, just permission. The air moves without needing to be pulled. It finds its way. It always has. You breathe because you are alive. Perhaps more gently. You are alive because you breathe. This exchange, silent and constant, has been happening since before you can remember. Before words, before thought. A rhythm deeper than memory. And inside that rhythm, something unexpected, a world within. Each breath doesn't just fill you. It also brings guests. It's unseen, unheard, but alive. You are not breathing alone in the stillness between breaths. Air lingers in your nose, your throat, and deeper down the trachea into bronchi, branching like a forest canopy turned upside. Down at the very tips of these branches are tiny sacs alveoli, thin-walled, moist, waiting. You might imagine them as empty, clean, sterile, but they are not. They are inhabited by you, yes, your cells, your breath, your blood, but also by others, microscopic others, small, soft living things, bacteria, the kind that do not harm, the kind that stay quiet, the kind that help. Science used to think the lungs were sterile, that anything living there was dangerous, that only disease brought bacteria into this sacred space. But the body has always been more generous than we knew. Now we understand the lungs host life, not just your own. A living world exists inside your breath, and it has always been there. Breathe out, let it go. This is not just release, it is sharing. With every exhale, you send part of that world outward. Moisture, warmth, and sometimes a few of your invisible passengers. You are never isolated. Even in silence, you are part of a cycle that moves in and out. Like tides drawn not by the moon, but by need. And with every cycle, you host, you invite, you allow. Picture the breath, a long corridor of soft tissue, folded and coiled and branching, pink, delicate, alive. Lined with cells that move in rhythm. Tiny hairs, cilia, waving upward. Mucus, sliding slowly, catching dust, pollen, stray microbes. A self-cleaning hallway, but never closed to visitors. Every breath is a crossing, from outer world to inner, and along that crossing, travelers arrive. Some arrive briefly. They touch, then pass. Airborne nomads. Others linger. They find a corner, a patch of mucus, a fold in the tissue where warmth stays, and they make it home. These settlers, though nameless to you, shape your immune system. They train it to tolerate, to balance, to notice difference without alarm. Because not everything foreign is a threat, and not everything familiar is safe. Your lungs know this. The microbiome helps them remember. Some microbes come from your mouth, swallowed, then inhaled. Some ride in on skin flakes, on mist, on food. Some live in your throat, your nasal passages, your sinuses. They don't knock, they just arrive, okay? If they behave, they stay. This is not invasion. It is coexistence. You are a habitat, a landscape of niches, valleys of mucus, peaks of cartilage, rivers of exhalation, and life, small, silent life, settles where it can. Even your alveoli, those fragile sacs where air meets blood, harbor residents. Not many, not loud, but enough to keep the peace, enough to help maintain the quiet. Breathe again. Feel how it flows. Your diaphragm lowers, your ribs lift slightly, the lungs expand. An air laden with memory, laden with microbes, rushes in. You do this thousands of times a day without asking, without knowing what you bring in. But your body does know. It watches, it listens, it adapts. Not all bacteria stay. Many come and go, passengers on a train that never stops moving. Your breath is motion. Your lungs are stations. Some microbes exit, some settle for the ride, and your body keeps score. Over time, patterns emerge. Communities form. Different sections of your lungs host different species. The upper airways favor some, the lower others. The balance is delicate and beautiful, like wind shaping dunes. This invisible world has favorites. It favors humidity. It favors warmth. It favors surfaces with mucus, with slow-moving cilia, with soft tissue that doesn't reject. It favors calm. Inflammation is its enemy. So is dryness. So is panic. Even stress can shift this balance. Even how you breathe can nourish or starve the smallest lives within you. Breathe softer, now deeper, now slower, not because you must, because it welcomes stillness. Stillness is fertile. Stillness is where the microbiome thrives. Sometimes a new microbe arrives from outside, from a person, from a place, from a change, and your body makes a choice. Fight, ignore, embrace. Your immune cells confer with your resident bacteria. Decisions are made quietly, diplomatically. Peace is not passive. It is maintained. These bacteria do not control you, but they help. They stabilize mucus production. They keep the immune response measured. They compete with invaders so harmful bacteria don't find space to grow. They are not your enemies, nor your servants. They are your quietest partners. Consider this. When you inhale, you are not just feeding cells. You are tending a garden, a microscopic ecosystem tucked inside your chest, fed by your environment, shaped by your history, and renewed with every breath. What you breathe feeds more than your blood. It feeds communities. Communities that, in turn, help you breathe again. This is not a circle. It is a spiral, one that deepens with every cycle of air. Let your body rest. Let the breath slow. Let it feed you. Let it feed what lives with you. Because inside this simple act is complexity. Inside this stillness, a living conversation. And inside your lungs, a world of life that asks for nothing but quiet and continuity. And now, what else lives inside this breath? What other voices exist, not yours, but essential to you? Let's follow them. Not far, just a little deeper. See who else calls your lungs home. There was a time, not long ago, when we imagined the lungs a sacred space, a cathedral of breath. Untouched, unspoiled, sterile by nature. Doctors said the lower airways were clean. Any presence of bacteria meant illness, infection, or mistake. Clean lungs. That was the goal. But the truth, like so many things in the body, is softer than we assumed. The lungs are not alone, and they never have been. They are companions to life, far too small to see, but never too small to matter. Close your eyes if you haven't already. Imagine your chest not as a machine, but as a room. A quiet, expanding room. Windows open, air drifting in, light filtered through curtains of ribs. This room is not empty. It is lived in. Soft footprints on the floor of the bronchi. Tiny echoes on the walls of your trachea. This is not invasion. It is home. For decades, the idea of microbes and the lungs was rejected. It didn't fit. We feared infection, feared contamination, but the microscope was only seeing part of the truth. Modern science opened its eyes wider. With DNA sequencing, we stopped asking only who made us sick and started asking who is already here. And the answers whispered back, quiet as breath itself. Inside your lungs, live bacteria. Yes, but not just any bacteria. They are residents, not raiders. Mostly friendly, many unknown, some fleeting, some old companions. They dwell not in chaos, but in ordered clusters, communities, patterns of presence. Amic, Robiome, not as dense as the one in your gut, not as famous, but perhaps just as vital. You carry this world without knowing. With every breath, you feed it. With every moment of calm, you shelter it, and it, in turn, protects you. Your lung microbiome is a living filter. It modulates inflammation. It educates your immune system. It wards off invaders. It whispers to your body, this is safe. This is known. Stay calm. It does all this without noise, without your permission, without your awareness, but it does not go unnoticed. Not by your body, not by your breath. There is something humbling about realizing you are not alone. Not even in your lungs. Not even in the deepest, most private reaches of your internal world. We are not sealed boxes. We are ecosystems, shared spaces. Each breath is not just an inhale. It is a handshake, okay? Mutual agreement between your body and the invisible others who live within it. You are not just you. You are a host, a habitat, a harmony. Some of these bacteria you inherit at birth, some from the air you grow up breathing, some from the people you live with, some from your pets, some from the foods you eat, the cities you walk through, the forests you rest in. And yet, somehow, despite this constant movement, your lungs hold a relatively stable community. Not a static one, but a balanced one, like a quiet neighborhood, where residents change slowly and politely, each one taking up space only if it can do so peacefully. The upper parts of your lungs, closer to your mouth and nose, have more visitors. They're the first to greet new arrivals, the ones riding in on speech, wind, or weather. These microbes are diverse, less permanent. The deeper you go into the bronchioles, the alveoli, the more selective it becomes. Only a few types endure there. Delicate ones, tolerant ones. These are not invaders. They are quiet cohabitants. Your immune system knows the difference. It doesn't fight every microbe it sees. That would be exhausting. Instead, it learns, it listens, it surveys the residents, and decides which ones are trustworthy. This is called tolerance, okay? And it is one of the greatest gifts your lung microbiome offers to help your immune system respond with wisdom. Not just aggression, to protect you without harming you, to recognize some bacteria belong and some simply pass through. This understanding changes everything. It reshapes how we think about illness, not as a sudden strike from an outside enemy, but as a shift in balance, disharmony. Because when the wrong microbes stay too long, or the right ones vanish, the lung becomes unsettled. Inflammation rises, mucus thickens, defenses misfire, and breathing, something once effortless, becomes uncertain. So to keep breathing softly, you must care for the life within. This care is not complicated. It's not medication. It's not surgery. It's not a product you can buy. It's rest. It's clean air. It's time and places that grow things. It's deep sleep, slow walks, laughter with others. Because all of these shape your breath. And your breath shapes your microbiome. It is not a one-way street. It is not you shaping your body alone. It is your body shaping you back in ways you don't see, in ways you might only feel in the stillness. Breathe in, pause, let that breath expand the tiniest spaces. Let it nourish more than just your blood. Now breathe out, slow, smooth, with it. You release warmth, moisture, perhaps a few friendly microbes floating back into the world that shaped them. You are not sealed. You are porous. You are open to the possibility that your inner world is not yours alone. And maybe it never was. Think of your lungs not as separate, but as part of a network, connected to your gut, your skin, your mind, your memory. Think of the bacteria in your lungs as part of a conversation, older than language, not words, but signals, proteins, patterns of behavior, responses passed through generations without sound. These bacteria are not yours, but they live with you. And because of them, you breathe more easily. You may never know their names, but they know yours. They know your rhythms. They know when you are afraid, when you are sick, when you are calm, and they adjust. They stay if the conditions are right. If you are still, the air is kind. This realization that the lungs are not alone is not a warning, is a comfort. It means you are supported, even in the parts of yourself you never imagined needed support. It means that health is not just your cells doing their job in isolation. It is a chorus, a cooperative, a coexistence. You are not alone. Can your breath proves it? What else then lives inside this breath? What does your body allow in, and what does it gently let go? At the threshold of your airway, just before breath enters fully, there is a sorting, a filtering, a quiet decision-making. Not all that arrives stays. Not all that stays belongs. So how does your body decide? Let's wander next to that boundary, the gate between outer and inner, and listen to what lives at the entrance to your breath. Your breath. It begins again with a breath. Not just a breath that moves, but one that listens, one that adjusts, one that finds its place in the ever-shifting quiet inside your lungs, beneath your ribs. Air glides through the bronchi like wind through reeds. It doesn't crash or collide, it flows. And in its wake, it carries not just oxygen, but balance, because breath, though invisible, shapes a whole world of tiny decisions being made without your mind involved. Balance lives in those decisions, in the space between too much and too little, in the soft middle ground your body builds over a lifetime. Imagine your lungs as a forest canopy, tall and branching, wide and sheltering. Now look closer, not at the trees, but the spaces between them. That is where balance begins, and what you cannot see. Within this forest, millions of microbial inhabitants coexist. Some thrive in humid shadows. Others prefer the edges, where air comes and goes. They compete, but they also coordinate, not with words, but with chemical nudges. A sigh of molecules here, shared pathway there, and together they hold each other in check. This is not a war. Not the kind of story where one species dominates and all others fall away. This is a gentle democracy, a microbial parliament where different types find balance through presence. If one grows too loud, the others speak up, release molecules that remind it to settle. If one begins to vanish, others step in, fill the role, soften the absence. Your lungs host not just bacteria, the wisdom of cohabitation. The dominant residents of a healthy lung include species like Prevotella, Ballinella, Streptococcus, and Corynebacterium. Each plays a role, some more visible, some more subtle. One manages inflammation. Another helps your immune cells tell friend from foe. Another one just fills space so that no harmful outsider can dot like neighbors, keeping porch lights on in a quiet village. Small acts of protection woven into daily life. They don't need to dominate. They need to coexist. To be enough, too much of one, and the system tips. It's too little of another, and the balance sways. It is not about perfection. It is about proportions, ratios, gentle presences, like the way your heartbeat adjusts when you fall asleep, like the way your eyes flutter closed when darkness becomes comfortable. The lung microbiome reads you, mimics your internal weather. It stays light when you are light. It holds ground when you are unsteady, and when you recover, so does it. Balance is not stillness. It is motion that returns to center, like the way your breath wobbles when you're crying, but slowly evens again when you begin to feel safe. Your microbes wobble too. They feel your grief, your stress, your diet, your sleep, your ear, and they respond. Sometimes slowly, sometimes dramatically, but always toward balance, if you let them. Now, imagine a moment of calm. You are resting. Breath deepens. Cortisol lowers. Your nervous system hums quietly. Your microbes shift in tune. Inflammatory species dim. Beneficial ones stretch out. The community becomes tighter, more connected. This is what calm does, not just to your mind, but to your biology. The balance in your lungs is not accidental. It's earned, moment by moment, by how you live. Disruption can happen. It often does. Pollution, smoke, cold viruses, antibiotics, even travel. All of these shift the ratios, invite new microbes, stress the old ones. But your microbiome doesn't panic. It adapts. It rebalances, if given space. This means giving it time, not reacting too fast, letting your body return to its own knowledge, because it remembers how to be well, and the microbes do. To balance doesn't mean every microbe is good. It means the harmful ones don't get the final say. Few pathogens may live there, but they are silenced by the crowd. It's not just about who is present, but who is loud. The healthy lung is not free from threat. It is full of quiet strength that keeps those threats from becoming storms. How does this strength grow? Through childhood, exposure, play, pets, soil, hugs, illness. Recovery. Each experience teaches your lungs what a balanced microbiome looks like. And over time, they remember it, like the body remembering how to walk after injury. Like the heart remembering how to love after silence. Your microbes remember wellness as a shape, a contour, a fingerprint of stability, and they try to return to it whenever they can. This return is guided by breath. Breathing is not just for oxygen. It is a rhythm that regulates who survives inside you. Deep breathing lowers acidity. It shifts mucus levels. It changes how bacteria move, how they grow. In shallow breath, stagnant spaces form. Microbes settle, unchallenged. In deep breath, air sweeps through, cleans gently, redistributes life. The way you breathe can shape which microbes thrive. So what does your body tell them when you exhale deeply at night? Even emotions matter. Stress can increase cortisol, which thins your mucus barrier. It weakens immune signals, allows opportunistic microbes to rise. Joy lowers cortisol, stabilizes blood sugar, improves airflow. Laughing moves air in sudden, irregular ways, which can stir up mucus and redistribute microbial populations, like shaking a snow globe. The microbiome listens, not just to cells, but to the life you lead through those cells. Food, too, makes its way to the lungs, not directly, but through signals, through blood chemistry, through fibers that feed microbes in the gut, who in turn send immune messengers that travel to the lungs. This gut-lung axis is a long conversation between distant neighbors who know how to listen deeply. Eat for your gut and your lungs. Feel it. Fast food, sugar, processed meals, they dampen the diversity of both fermented foods, fiber, plants, polyphenols. They offer tools to your microbes, tools to build a stable home. Balance is not made of a single act. It is a weaving. It is walking outdoors, some breathing air touched by trees. It is resting enough that your cells repair and reset the microbial code. It is touching the earth, it's hugging others, sweating, sighing. These are not luxuries. They are the scaffolding of your microbial stability. Your lungs, remember them, okay? And your microbes, thank you for them, not with words, but with calm. So tonight, as you settle, okay, think of your breath, not just as yours, but as a song shared between many. Quiet lives within you. A song that stays in tune because every part listens. Every inhale adjusts. Every exhale recalibrates. Even when you sleep, this balancing continues. Tiny shifts, molecular signals, a constant movement toward health. You do not have to manage it. You only have to allow it. And in the allowing, the balance begins to hold you. But where does this balance begin? What's the first gate where life decides whether it can enter or not? The lungs are deep, but air does not start there. Before the alveoli, before the bronchi, before the lungs themselves, there is a threshold, a gateway, a filter, a passage. What lives there at the entrance to breath itself. The air you breathe does not arrive in the lungs immediately. It begins at the doorway, the nose, the mouth, those soft tissues of the throat. This space is not just a hallway. It is alive, awake, watching. The upper airway is the front porch of toe, your respiratory world. Okay? And like any porch, it gathers what the outside brings. Dust, wind, voices, smells, okay? And all the invisible guests that come along. Some of these guests are known. Some are strangers, okay? Some are welcome, and others must be turned away. But you're not alone in making these decisions. The gatekeepers are small. So small, you've never felt them, never seen them, but they have always been there. They live in the moist lining of your nose. They nestle into the folds of your sinuses. They rest along your cheeks, your tonsils, your soft palate, your tongue. They are bacteria, billions of them. Think they are your first line of conversation with the world beyond. When you breathe in, air travels over warm, moist surfaces. It picks up molecules. It meets defenses. Tiny hairs catch large particles. Mucus traps the smaller ones. But beyond these mechanical filters, your microbes are already scanning. They don't fight immediately. They listen, they compare, they prepare. Because this gate is not just a security checkpoint. T is a learning space, a place where your body remembers what it has seen before and what it should do next. Inside your nose, a species called Bacterium alkalans helps break down the fatty acids in the mucus. This creates byproducts that inhibit harmful bacteria like Streptococcus pneumonia from taking hold on your tongue. K species like Streptococcus salivarius communicate with your immune system through subtle chemical messengers in your tonsils. Fusobacterium, Neisseria, and others form biofilms, microbial communities that cooperate to keep out intruders. These are not infections. These are protectors, living filters, not erasing life, but sorting it. Your mouth and nose don't merely open to the world. They shape it. The microbes here don't just block bad actors. They educate your immune system. They say, this one's a friend. That one needs attention. This pattern feels familiar. Let it pass. That molecule is odd. Keep an eye on it. These judgments happen faster than you can blink. And because they are right more often than they are wrong. You remain well without ever knowing how. But, like all complex systems, this one can falter. Disruptions here don't stay here. They echo down through the throat, into the lungs, into the bloodstream, when your oral or nasal microbiome becomes unbalanced. When certain species overgrow or others vanish, your defenses become foggy, signals become unclear, responses become too strong or too slow. Sometimes this leads to chronic inflammation, sometimes to oversusceptibility, often to subtle discomforts, stuffy noses, dry throats, frequent colds that seem like bad luck, but may simply be microbial imbalance. Modern life offers many disturbances: mouthwashes that kill indiscriminately, air conditioning that dries the passages, polluted air that brings new chemicals, highly processed foods that change pH levels, antibiotics that flood the entire terrain. All of these shift the balance at the gateway. They don't just remove pathogens, they remove guides. They turn down the volume on the whispers of warning that your microbes provide. And then, when something real comes along, a virus, a spore, a chemical irritant, the body is slower, less prepared, more reactive, not because it forgot, but because its translators are missing. Still, healing is possible. The microbiome at your gateway responds quickly to kindness. Breathe humid air. Eat plants that feed beneficial bacteria. Swish with water, not antiseptics. Laugh more. Sleep well. Spend time outside. These are not just habits, they are invitations. When you slow down, so do your defenses, but not in weakness, in clarity. They become more precise, more accurate. Your immune response is calm. Your breath flows smoother, and your microbes begin to weave balance again. There's a reason the nose warms air before it reaches the lungs. It's not just physics, it's protection. Warmer air holds more moisture. Moisture traps invaders. Moisture feeds helpful bacteria. There's also a reason why breathing through your nose, not your mouth, is often better. The nasal cavity filters and conditions air more effectively. It hosts specific microbiota that prefer the curves of the sinus. Mouth breathing bypasses this filter and shifts the ecosystem downstream. Dry mouth, throat irritation, different microbial profiles. Each change matters. Each habit shapes. It's a conversation between you and the outside world. Some microbes here even send messages back to the brain through the vagus nerve, through immune signaling, through olfactory molecules. Your sinuses are not just hollow tastery chambers. Microbial senses live here too, processing not just scent, but safety. When your nasal microbiome is balanced, your anxiety may lower, your inflammation may quiet, your airways may open more easily. This isn't placebo, it's biology. It's the deep integration of breath and being. Even the shape of your jaw, the position of your tongue, the presence of your tonsils, all these affect microbial residence. That evolution has been sculpting your respiratory gateway for millennia, because survival depends not just on breath, but on what breath carries. A mouth that chews whole foods encourages microbial diversity. A nose that stays active through use supports stable ecosystems. The shape of your airway invites certain life forms and discourages others. You are not just a host, you're a home with specific architecture. At the center of the mouth lies the tongue. Soft, strong, constantly moving. It is a dynamic landscape, not a flat surface, but a terrain of ridges and valleys. Different species prefer different regions. Some like the back, others the tip. Still others hide along the sides. Each spot carries its own profile, and when you swallow, you send these microbes downstream to the gut, to the lungs, in tiny amounts, but enough to teach, to influence. It's a signal. Your breath and your digestion are not separate. They speak to each other through this shared gateway. Then there is the throat, a corridor of muscles and mucus, a place of passage, but also of decision. Here, the immune system is active. Tonsils and adenoids sample the environment constantly. They are not primitive relics. They are microbial sensing hubs. If the conversation becomes hostile, if a virus shouts too loudly, or a bacterium acts suspicious, the tonsils swell. They respond, but they also tolerate. They learn. They archive, and in their tissues, beneficial microbes nest. They help shape the tone of your body's immune voice. They help decide when to be fierce and when to be forgiving. So what enters your lungs doesn't arrive by accident. It is curated, conditioned, whispered forward by communities that care. The gateway is not a wall. It's a garden path, one that twists and slows the traveler just long enough to decide whether to continue. Most microbes turn back. Some move ahead. A few stay behind to guide others, and the whole path remains alive with purpose. Each breath is a crossing, each inhale a beginning. But before the lungs fill, before the alveoli expand, before oxygen touches blood, 1,000 tiny lives have made decisions on your behalf. They have tasted the air, filtered it, learned from it, adjusted for it, so that by the time the breath becomes part of you, it already carries balance. Next, we follow that breath deeper to the bronchi, the branching pipes. The inner cathedral of movement here. 2. Life waits, not in crowds, but in quiet perches. Tiny neighborhoods between cilia, silent watchers in the trees of your lungs. What do they do when breath becomes wind, when balance meets motion? We go there next. Your lungs do not feel like a forest, but they are. Not metaphorically, not symbolically, but anatomically. Each breath that passes your throat enters the trunk of the trachea, then splits left and right into the bronchi, NCHI, and those bronchi branch again and again and again for 20 times until what was once a single passage becomes tens of thousands of fine hair-like tubes, each one a path, each one an invitation. And at the end of each, a leaf, but not the kind that photosynthesize, the kind that exchange breath for life. These terminal sacs are alveoli, tiny, balloon-like spaces where air stops moving, not because the journey ends, but because the real work begins here. This deepest, softest space, oxygen passes into blood. Carbon dioxide drifts out, and everything you are is quietly renewed. But what is perhaps most astonishing is this. Even here, where the air slows to a hush, there is life. For decades, we believed the lungs were sterile, that below the throat, microbes could not survive. The logic made sense. Lungs are delicate. Too much inflammation could collapse them, so nature must keep them clean. But it turns out, clean doesn't mean empty. It means balanced. And that balance includes bacteria. Lung microbiota are sparse, but not absent. They arrive not as residents, but as visitors. Every breath brings a few. Every swallow, a trace. Every movement of mucus carries whispers of life from above. These microbes do not colonize the lungs like they do the gut or skin. Instead, they pass through gently, pausing, contributing, reminding. They are like birds resting in a tree. Brief, careful, essential. Among these transient travelers are species of Prevotella, Pollinella, Streptococcus, and Haemophilus. They are not threats, not infections. They are scouts. They send subtle signals to immune cells that dwell in alveolar tissues. They help calibrate readiness. Not too much, not too little, just enough, because the lungs are unlike the gut. Here, inflammation is dangerous. Even a small immune overreaction can flood the alveoli with fluid. And when alveoli flood, oxygen cannot pass. And without oxygen, the heart must struggle, the brain must dim, the body must slow. So instead of war, the lungs prefer diplomacy, tolerant, quiet, responsive. The immune cells here, especially alveolar macrophages, are not loud. They watch, they sample, they remember, and they listen to the whispers of the microbiota that drift down from the mouth, from the nose, from the air itself. This balance is fragile, and yet it endures. Breath after breath, hour after hour, night after night. But in certain conditions, pollution, smoking, infection, chronic illness, the microbiota changes. Species that once stayed only briefly begin to linger. Others disappear, and the immune system begins to stir from its quiet stance. Inflammation arrives, the alveoli swell, mucus thickens, and breath becomes labor. Still, even in illness, the lungs try to learn. They do not forget what health felt like. They do not discard their patterns easily. That is why, in recovery, rest and slowness help, because the lungs are not rebuilt by force. They are restored by rhythm, by gentle air, by soft and light, by steady sleep. These two are medicine. When you lie down to sleep, your breath becomes shallower, slower, more regular. Your diaphragm, the muscle that drives breath, moves gently downward. Your rib cage expands like a bellows, and the air moves deeper into the branches, It is during this time, the long exhale of night, that your lungs recalibrate. Damaged cells are replaced. Mucus is cleared. Microbial balance is reset. You are not idle. You are healing. CILIA, tiny hair-like structures, line the bronchi and bronchioles. They beat in coordinated waves, always upward, always outward. Their rhythm never stops. Even as you sleep, they push debris, inhaled particles, and microbial stowaways back up the airway, where they're swallowed, or expelled, or reevaluated by the upper microbiome. This mucociliary escalator is your lungs' silent janitor, and it depends on hydration, temperature, and the subtle guidance of your microbial guests. In health, your lungs are not sterile, they are curated. This matters because the story of breath is not about sterility. It's about symphony. Every breath you take is an orchestra of physics, chemistry, biology, and memory, and the microbes, Though small, hold the tuning fork. They sense vibration. They modulate inflammation, They communicate across membranes, even when you are unaware, especially when you sleep. Take a breath now. Let it fill your chest. Feel the quiet movement beneath your ribs. And imagine, not empty lungs, but living branches. Not sterile sacs, but breathing chambers alive with silent watchers. You are not just a vessel for air. You are a landscape of living cooperation. Each breath a shared responsibility. Even the gases exchanged in your alveoli are influenced by microbial presence. Some microbes generate short-chain fatty acids. These compounds travel via the bloodstream and modulate inflammation in the very lungs that hosted their creators. Others influence local pH levels, which affect mucus thickness, cilia movement, and pathogen resistance. Still others interact with epithelial cells, the cells that line your airways and signal for repair or restraint. This isn't random. This is communication. Silent, microscopic, continuous. There are no words exchanged, no voices, only molecules drifting across membranes, binding to receptors, triggering cascades of response. And yet, this language of molecules may be more precise than any human speech, because it does not lie. It does not exaggerate. It does not forget. It remembers every breath, every moment, every visitor, and it responds with clarity. In certain diseases, asthma, COPD, cystic fibrosis, this language becomes distorted. Microbial diversity drops. Inflammation rises. Mucus thickens. The cilia slow down and breath becomes effortful. But even here, microbial shifts offer clues. They are not only markers of disease, they are participants, and if understood, they may become part of the cure. That future is near. Already, scientists are exploring lung microbiome therapies, healed probiotics, targeted bacterial transplants, mucus-modulating diets. These are not fantasies, they are trials, and some have already shown promise. But even without intervention, there are ways to honor your lung microbiome. Avoid smoke, breathe clean air, sleep in a cool, humid room, sing, laugh, walk, breathe through your nose, rest deeply. These are not commands. They are reminders of what your body already knows. The branches of your lungs are not silent. They rustle, they hum, they murmur, not in sound, but in sensation. It's in regulation. It's in the steady pulse of breath well tended. You do not need to control it, only to notice, to allow. Because your lungs are not a machine. They are a forest, alive and listening. In the next chapter, we descend into the bloodstream, where oxygen, out touched by breath, rides cells like boats, traveling to brain, to skin, to bone, where microbes guide not breath, but energy, where the story of life leaves the lungs behind, and enters the rivers of motion. There's a moment after you inhale, and before you exhale, where oxygen has already left your lungs, but has not yet reached its final destination. It is the moment the courier picks up the letter, but has not yet knocked on the door. In this space, the breath becomes blood. Not all of it, of course, only the part that matters. Each molecule of oxygen, invisible and tiny, enters a red blood cell, a soft, pliable disc without a nucleus, without ambition, carrying nothing but the commitment to deliver. Within that red cell are iron-bearing proteins called hemoglobin, and it is there, in that quiet embrace between atom and molecule, where oxygen finds its chariot. You might imagine this as cargo riding through tunnels, but that's too rigid. It's too mechanical. Instead, imagine a river, not a violent torrent, but a smooth, meandering current that flows with purpose and quiet elegance. The bloodstream is not a highway. It is a conversation. It listens, it adjusts, and the red blood cells are its messengers. There are over 25 trillion red blood cells in your body at any time. Each cell lives for about 120 days. Each cell completes thousands of circuits from the lungs to the tissues and back again. And each time, it carries 4 molecules of oxygen to wherever they are most needed. Not by guesswork, not randomly, but in response to whispers from your own cells. Tissues that are active, contracting, digesting, repairing, send out signals. They lower their oxygen levels. They raise carbon dioxide. They change the temperature and the pH of their local environment. And the red blood cell, without eyes, without ears, senses all of this. And let's go. It unhooks the oxygen where the demand is highest: a muscle in the leg, a neuron in the brain, a follicle of growing hair. Then it returns to the lungs, empty and silent, to begin again. But here's what's extraordinary. Red blood cells are not just delivery trucks. They're more like diplomats. Tiny, they adjust their shape to squeeze through capillaries narrower than themselves. They fold, they bend, they twist it with discomfort, but with design. Their membranes are soft. Their structure optimized for flow. And all of this, the shape, the squeeze, the timing, is regulated by the molecular dance between oxygen, carbon dioxide, pH, and temperature. It's called the Bohr effect. And it means this: your cells can ask for more oxygen simply by being alive. Pause here. Take a breath. Hold it for a moment. Know that right now, as you do nothing, millions of red blood cells are winding their way through your capillaries, in your fingertips, your eyelids, your stomach lining, your heart muscle. They are not waiting for orders. They are responding to need. This is how life sustains itself without noise. Carbon dioxide, too, is carried back. Not just dumped, but buffered, converted to bicarbonate, escorted to the lungs in a chemical disguise. There, the alveoli, it is released, converted back, and exhaled. This transaction, this conversion, is catalyzed by an enzyme called carbonic anhydrase, one of the fastest enzymes known. It allows the exchange to happen in milliseconds, so that you may breathe without ever noticing the chemistry beneath it. All of this occurs within a closed loop of vessels. Arteries, thick and muscular, carry blood away from the heart. Veins, soft and wide, bring it back. Capillaries, hair, thin and intimate, connect them in a lacework woven through every organ. If you stretched them end to end, your blood vessels would span over 60,000 miles. That is not metaphor. That is measurement. And all of it, every inch, is touched by the breath you took a moment ago. The brain is the most oxygen-hungry organ. Though it weighs only 2% of your body, it uses over 20% of your oxygen, not because it moves, but because it thinks. Even now, as you listen, neurons are firing, glial cells are supporting, synapses are strengthening or fading, and each of those functions requires energy, and energy requires oxygen. So your red blood cells prioritize the brain. They slip through the blood-brain barrier with selective grace. They deliver their load, then exit quietly. The brain notices, okay, and it remembers. Other organs wait their turn. The liver, filtering toxins and building molecules. Okay. The kidneys, balancing salts and waters. The skin, regenerating its barrier. The intestines, digesting your last meal and preparing for the next. Every cell asks differently. Every tissue receives proportionally. This is not equality. It is balance, and balance is a kind of fairness deeper than justice. Not all red blood cells are perfect. Some are misshapen. Some are old. Some are caught by the spleen, which acts as a filter, removing the tired and welcoming the new bone marrow. Deep within your long bones, produces over 2 million new red blood cells every second. It is quiet work, uncelebrated, but constant, like breath, like sleep, like the passage of time. When you sleep, your blood flow slows, your heart rate drops, but the red cells keep moving. Oxygen still travels. Carbon dioxide still exits. But now, the priorities change. The body is no longer active. It is rebuilding. And so, blood flow shifts toward the organs of repair. The skin, healing its micro-tears. The brain, consolidating memory. The gut, absorbing nutrients. The immune system, patrolling gently with lowered vigilance, but heightened wisdom. All of it powered by oxygen gathered in the lungs, okay, and carried by cells you never feel. There are times when this system is challenged at high altitudes. There's less oxygen in the air. The lungs work harder. The heart beats faster. And over time, the body adapts. It produces more red blood cells. It increases hemoglobin concentration. It widens capillary beds. It does not complain. It adjusts. And in doing so, it reminds you, resilience is cellular. It is not an attitude. It is a pattern of response written into your very blood. Even now, scientists are studying the oxygen transport system for clues to disease. Why do some cells fail to release oxygen? Why do others carry too little? What happens when hemoglobin mutates? Scusalemia, thalassemia, carbon monoxide poisoning. These are disruptions in the breath's journey. And yet, understanding them brings us closer to healing, because in mapping the failures, we better appreciate the function, and in understanding function, we glimpse the quiet elegance of the body's design. You may think of breath as air, and air as external, but the truth is stranger. Once oxygen enters your blood, it becomes part of you. It infuses your flesh. It burns gently mitochondria to create energy, and its ashes, carbon dioxide, are released like a final sigh before the cycle repeats. This is the alchemy of life. Combustion without flame. Fire without heat. Change without noise. So, take one more breath. Inhale slowly. Hold it briefly. And let it go. Know that in that single act, you have fed every cell in your body. You have delivered fuel to the darkest corners. And you have participated in a cycle as old as multicellular life itself. No effort is wasted. No cell forgotten. The breath is not just yours. It is shared among trillions. Each red blood cell a reminder that even the smallest act can be sacred in the next chapter. We descend further into the mitochondria, where oxygen meets glucose and gives birth to energy. A story of fire without flame. A story of ancient ancestors who still whisper within every cell you hold. You hold. The breath has traveled far, from air to lungs, from lungs to blood, from blood to tissue. Now, at last, it arrives where it has always been going. The mitochondrion, a tiny structure, buried in the fluid of the cell, surrounded by the machinery of life, nucleus, cytoskeleton, membranes, and yet, older than all of them, it is here in the mitochondria that oxygen fulfills its promise. Each cell in your body contains hundreds, sometimes thousands of mitochondria. They are not part of your body in the usual sense. They are guests. Ancient symbionts, bacteria that once lived alone but were welcomed in by a larger cell billions of years ago. They brought with them a gift, the ability to extract vast energy from simple sugars, and in return, they were given shelter, protection, purpose. That deal, made in the silent tides of prehistory, is the reason you exist. Inside the mitochondria, oxygen meets glucose, but not directly. It is not a crash. It's not a combustion. It is a slow, careful unfolding, a process called cellular respiration, broken into steps: glycolysis, the Krebs cycle, and the electron transport chain. Each step an offering, each reaction a whisper passed from molecule to molecule, until at last the oxygen accepts an electron and becomes water. A new beginning. Let's go back. Glycolysis happens first, not in the mitochondria, but in the cytoplasm. It breaks one molecule of glucose into two molecules of pyruvate. Along the way, it harvests a little energy, a few coins, a trickle. But it is not the main event. The pyruvate enters the mitochondria, where it is broken down further. Carbon atoms are cleaved off. Electrons are harvested. These electrons, tiny charges of possibility, are shuttled to the electron transport chain. And it is here, in this final pathway, that the fire begins. The electron transport chain is not a single structure. It is a sequence, a series of protein complexes embedded in the inner mitochondrial membrane. Each complex is a station. Each electron passes from one to the next, like a traveler changing trains on a quiet, moonlit journey. At each station, energy is siphoned off and used to pump protons across the membrane. This creates a gradient, a tension, a quiet pressure. It's called the proton motive force. And from this invisible slope, energy is born. The final electron lands in the hands of oxygen, the ultimate electron acceptor. Oxygen embraces it, binds with hydrogen, and becomes water. Nothing is burned. Nothing is destroyed. Instead, something is made. Energy, specifically. A molecule called ATP, adenosine triphosphate. ATP is the universal energy currency. It powers muscle contractions, nerve signals, cell division, memory formation, healing, growth. Everything. Every second, your body produces and consumes millions of ATP molecules. It does this silently, without smoke, without waste, just water, carbon dioxide, and warmth. You are warm-blooded because of mitochondria, not because you move. It's not because of your muscles, but because trillions of tiny cells burn fuel with such controlled intensity that they warm you from the inside out. You are a walking hearth, a breathing fire, a calm, enduring ember, even in sleep, even in silence. Pause again. Imagine, if you will, a single cell, a round droplet of life floating in a sea of others. Inside that cell, dozens of mitochondria pulse gently like lanterns. In the fog, they do not flicker. They do not burn, but they churn quietly, and from their work comes every heartbeat, every step, every memory. Oxygen, then, is not the hero. It is the final piece in a grand procession. Without it, the whole system backs up. Electrons have nowhere to go. Protons stop flowing. ATP stops forming, and the fire dies. This is why, when we are deprived of oxygen, we lose consciousness within minutes, because the mitochondria can no longer feed us. The brain, so hungry for energy, is the first to feel the loss. It has no backup, no way to store reserves. It lives on a second-to-second supply of oxygen and glucose. Without it, neurons falter, signals stop, thoughts dim, and the world recedes. This fragility is not a flaw. It is a testament to how deeply we are built around the dance between oxygen and fire. Mitochondria also carry their own DNA. It's small, only 37 genes, but it's separate from the DNA in your nucleus. This is because they were once independent beings, and they still remember what it means to survive. Mitochondrial DNA is passed down only from the mother. It is a direct lineage, a thread that stretches from your mother to her mother before her, tracing back through time to the women who first walked the earth. Their mitochondria still live in you. Their fire still burns. But mitochondria do more than make energy. They sense stress. They trigger cell death when things go wrong. They regulate calcium levels, control inflammation, and influence aging. When they falter, we age faster. We grow tired. We get sick. Diseases of the mitochondria can affect the heart, the brain, the muscles, even our ability to think or move. That's how central these tiny powerhouses are. They are the guardians of vitality. Athletes, monks, singers, thinkers all depend on mitochondria to sustain endurance, focus, and resilience. Even your immune system uses ATP to mobilize cells, repair tissue, to coordinate the response to infection or injury. Without mitochondria, there is no healing, no defense, no strength, only stillness. And still, you do not feel them. They do not ache or throb or speak. They simply do, and they do so with a grace that does not seek attention. Perhaps this is the lesson they offer us: to fuel the world quietly, to carry fire without smoke, to sustain others without applause. Take another breath. Let it fall into your chest. Know that deep within your cells, that oxygen is not resting. It is entering a current, a relay, a story billions of years in the making. And at its heart is the mitochondrion, an ancient ally that once lived alone, but chose to live with you. And in doing so, gave you the power to walk, to speak, to dream. In the next chapter, we follow the warmth to understand how the body stays warm even in the cold, how it protects the brain and the heart, and how, in illness or trauma, this delicate flame can falter and be rekindled. But for now, let the mitochondria work undisturbed. They ask for no praise, only trust. Trust. Imagine waking in a cold room. The air bites, the sheets feel thin. Your nose is the first to feel it, that icy whisper. Your fingers follow, then toes. And yet, your chest is warm. Your belly, too. Your core remains calm, like a hearth wrapped in blankets. That is not chance. That is biology. Holding the cold at bay. Heat is not something we store. It is something we constantly make, moment by moment. And the fuel for that heat, oxygen and sugar, meeting in the mitochondria. You've now seen. But how that warmth spreads, how it's conserved, regulated, and used, is another quiet orchestration, a dance of vessels, nerves, and signals. A constant negotiation between survival and function. Let us begin in the core. Your vital organs, heart, brain, lungs, kidneys, must stay near 37 degrees Celsius or 98.6 degrees Fahrenheit to function properly. Just a few degrees cooler, and enzymes begin to slow. Cells work less efficiently. Blood becomes thicker. Thoughts muddled. A few more degrees, and life itself begins to slip away. So the body protects the core with fierce loyalty. It restricts blood from the skin, from the limbs, from the surface. It hoards heat inward, letting the extremities go cold. So the center remains steady. This is why fingers and toes turn pale, then numb in the cold. They are being sacrificed for the whole. The skin is the largest organ in your body. It is also the largest radiator in summer. It flushes. In winter, its conserves. Blood vessels within the dermis open or close based on the ambient temperature. In warmth, they dilate. More blood comes close to the surface, releasing heat like steam from tea. In cold, they constrict. Less blood near the skin. It's more warmth kept deep within. It's an old trick, a wise trick. Kate has kept us alive. It's an old trick, a wise trick. It has kept us alive longer than fire ever has. Before fur Before shelter, before quilts and hearthstones, you were already warm-blooded, already defending a tiny, glowing core from a freezing world. Your lungs, though we often think of them only as vessels for breath, are crucial in this warming dance. Because breath is not just about gas exchange, oxygen in, carbon dioxide out. It's about energy. And where there is energy, there is heat. Each breath brings in oxygen. Each molecule of oxygen enters red blood cells and binds almost magnetically to iron inside hemoglobin. This tiny handshake, this invisible bond, is sacred because it's not just about carrying gas, it's about delivering power. As the heart beats, it sends these loaded red blood cells through arteries, through arterioles, into the tiniest capillaries, like messages whispered into a maze. There, in the warm dark of your deepest tissues, oxygen is passed off, and in those waiting cells, your mitochondria light the fire. They take that oxygen and combine it with glucose or fat or protein, whatever fuel is available. And from that merging, they generate not just ATP, the cell's energy currency, but warmth, sweet, subtle warmth. Your breath feeds this process. Your lungs sustain it. Without oxygen, the mitochondria shift into fermentation, a less efficient, colder process. You grow fatigued, you feel chilled, struggle to stay alert. So oxygen, and thus breath, is the first matchstick struck in the cold. But oxygen alone is not enough. The body must know when to save heat, when to lose it, when to fight for it. So it watches constantly. In your brain, in the base of your hypothalamus, are special neurons. They are thermosensors, tiny guardians, measuring your core temperature with remarkable accuracy. If that temperature drops, even by half a degree, they send instructions outward. Constrict the vessels, shiver, raise the metabolism. If the body is too warm, dilate, sweat, slow the fires. It's not conscious, it's not loud, but it is precise. Your body, at every moment, is deciding how warm you should be, and then it's shivering. It feels like failure, like cold winning. But in truth, shivering is resistance. It's a muscle-generated heat, small contractions, barely enough to move your limbs, but enough to burn ATP, to release heat. Children shiver more easily than adults. They have less fat, insulation, faster metabolism. Their bodies respond quicker, but tire sooner. Elderly people shiver less. Their thermoregulation has dulled, and so they are more at risk. Another quiet way that time changes our relationship with warmth. And what? Of brown fat, nestled near the collarbones, along the spine, and in newborns. It is not for storage, but for burning. Brown adipose tissue, a special, heat-generating fat. It doesn't wait for movement or shivering. It lights its fires at the command of cold. Brown fat turns fuel directly into warmth, bypassing motion, creating a silent furnace deep within the body. Adults retain only small amounts, but those who are regularly cold, those who expose themselves to winter air, to icy water, may activate more. The body adapts, always, silently, faithfully. Now, imagine the breath again. Cold air enters. You feel it in your nose, sharp and clean. It rushes down your trachea, into bronchi, into bronchioles, till it reaches alveoli, those tiny sacs at the end of the respiratory tree. By the time it arrives, it is no longer cold. Your airway linings have warmed it, moistened it, transformed it into something gentle, even in the frost. Your lungs protect themselves. They will not allow freezing air to reach fragile tissue. They buffer it. They sacrifice heat to maintain safety, and you don't even notice, 'cause they do. Every breath, every moment, without applause. When you speak in the cold, your words fog. That mist, that fleeting ghost of breath, is moisture, lifted from the warmth inside you. You lose heat through speech, through song, through each sigh, and so, quiet is warmer. Stillness preserves heat. Speech spends it, But isn't it beautiful that your warmth is visible only when the world is cold? Okay? That in winter, your breath makes itself known. Quiet testimony to the fire within. You carry warmth in your chest, in your blood, in your marrow, and yet you borrow warmth too. From sweaters, from scarves, from fire, from others. There is no shame in this. Humans were not meant to be alone in winter. We huddle, we share, we build rooms, not just for shelter, but for warmth. The body is a marvel, but it was never meant to endure everything alone. And breath. Breath is the invitation to stay. When you are cold, your breath shallows, but when you breathe deeply, you remind the body, yes, stay alive. Oxygen floods in. Mitochondria respond. Heat rises. Even now, as you lie in bed, your body is calculating, protecting, generating. A quiet furnace burns behind your ribs. Fed by breath, washed over by your brain, defended by your skin, and carried through your blood. You are warm because every part of you has agreed to try. And maybe tonight, as you slip beneath the covers, you'll feel that warmth more clearly in the soft hum beneath your sternum, in the gentle pulse at your neck, like in the breath that steams softly against your pillow. You are not just asleep, you are aglow. But what happens when that warmth is challenged, when cold overwhelms the breath, when oxygen runs thin in high mountains or deep sleep? Next, we drift toward the edges of thin air, toward a breath that struggles, but still, somehow, protects you. You've never really questioned your breath. It simply arrives, like morning light through a window or the sound of your own name, familiar, rhythmic, unearned, at rest. Your lungs draw in the world 12, maybe 15 times each minute. With each inhale, air flows down, filling millions of alveoli like water slipping into hollow stones. Oxygen crosses the alveolar membrane. With no effort, you can feel diffusing into red blood cells, whose only task is to carry it away. But this smooth exchange is built on a delicate gradient, a pressure difference between the air outside and the blood inside. And when that gradient begins to fade, when oxygen grows scarce and the air grows thin, your body begins to notice. Not with panic, not at first, but with a whisper. A shift, a soft tightening in the chest. At sea level, the air is generous. Each liter you breathe contains roughly 210 milliliters of oxygen, plenty for your quiet fires. But climb just 8,000 feet. It's the height of a modest mountain town, and that oxygen drops by nearly a quarter. Not because there is less oxygen in the air, but because the pressure has changed. The molecules are farther apart. They move with less urgency into the waiting blood, and your lungs feel it. Your brain senses it, and the body begins to adjust. Not suddenly, but with wisdom earned over millennia. The first change comes in your breath. It quickens, not frantically, but steadily. You breathe deeper. Each inhale draws in more air. Each exhale pushes out more carbon dioxide. This changes the chemistry of your blood. CO levels fall. The pH rises. The blood becomes slightly more alkaline. In your brainstem, specifically the medulla oblongata, registers this shift like a candle detecting wind. It adjusts your breathing rhythm, your heart rate, your vascular tone. This is the dance of acclimatization. It begins within minutes, but it will continue for days, even weeks. Next, your blood begins to change. The kidneys, quiet chemists of the body, sense the lowered oxygen and release erythropoietin, a hormone with a singular mission: to build more red blood cells. Over time, the blood becomes thicker, richer in hemoglobin, better equipped to catch the sparse oxygen floating in the thin air. Your spleen may even contract, releasing a hidden reserve of red cells into circulation, all to protect your breath, your warmth, your thought, because oxygen isn't just for energy. It feeds everything: your memory, your coordination, your very sense of self. High altitude dwellers, Those who live their whole lives in cities like La Paz or Lhasa are born into this economy of breath. Their lungs are often larger, their chests wider, their hemoglobin levels higher. They've inherited the adaptations written into generations of lives spent on the roof of the world. But for newcomers, the mountain tests patience. Climbers know this. Pilots feel it. Even some travelers sense a strange heaviness in the head. In the lungs, as if gravity itself has become more assertive. And yet, there's beauty in this struggle. High-altitude breath slows the mind. It encourages stillness. It asks you to move. Less to notice, more to rest between words. To measure your steps, to listen to the sound of your own breathing as if it was something fragile, sacred. But thin air doesn't only live in mountaintops. It visits you each night when you sleep, especially in deep sleep. Your breath becomes shallow, your airway more relaxed. Sometimes the soft tissue of your throat collapses slightly, narrowing the path. This is normal. But for some, it becomes obstructive. Air struggles to enter. Oxygen dips, and your body, half dreaming, responds. It startles. It shifts position. It interrupts the cycle of sleep just enough to restore the breath. This is sleep apnea, a quiet war between airway and oxygen, between rest and survival. Even during waking hours, your breath adjusts constantly to small changes in an airplane, pressurized to feel like 8,000 feet. You may yawn more often. Your body is managing a lower oxygen gradient without you even realizing. At high elevation, simple acts, climbing stairs, lifting a suitcase, walking briskly may feel exaggerated. You breathe harder, not because you are unfit, but because oxygen has become precious. Your body notices before your thoughts do. And sometimes the thinness of breath comes not from altitude or sleep, but from illness. Lung infections, fibrosis, emphysema, all narrow the space where oxygen can move. They thicken membranes. They slow diffusion. They rob the blood of what it needs most. And the body responds just as it always has, by adapting, by adjusting breath, blood, heart, and brain to stretch what little oxygen remains. It is a miracle of resilience, even when the lungs are damaged. The body still tries to find a way to keep you warm, to keep you thinking, to keep you whole. And there are creatures who breathe in thinner air with grace. You cannot imagine bar-headed geese fly over the Himalayas at altitudes over 29,000 feet, where the oxygen is 1/3 of what it is at sea level. Their hemoglobin binds oxygen more tightly. Their lungs extract more with each breath. Their hearts are stronger, their flight muscles more efficient. They are built to defy thin air. And then there are humans whose adaptations may be slower, but just as beautiful. You climb, you adjust, you survive, you learn to live on less. Even astronauts train in hyperbaric chambers, learning what it feels like to breathe in a place where pressure has vanished, where oxygen floats like a distant promise. They wear suits that pressurize the body, that concentrate oxygen, that protect breath like a candle in wind. Because even in space, even among the stars, breath remains the first and final need. So what happens when breath stretches beyond its comfort? When oxygen becomes sparse and the air thin, your body does not despair. It transforms. It becomes more efficient, more focused, more reverent. Each breath becomes a choice. Each inhale a commitment. Each heartbeat a quiet hero. Thin air teaches you what matters, It teaches you to slow down, to listen, to adapt. And tonight, as you lie in bed, perhaps you'll feel the weight of breath differently. Not as heaviness, but as meaning. You are not simply filling lungs. You are exchanging quiet promises with the world, taking in what you need, letting go of what you don't. A breath is never just a breath, especially when it must travel farther to do the same work, especially when it reminds you how thin the air can get, and how strong you still are. And now, as we leave the high places, we return to gentler questions. What else shapes our lungs? What invisible forces guide their growth from the very first moment? In the next chapter, we drift back to beginnings, to the day your lungs took their very first breath. The moment of birth is quiet, not in sound, but in time. Everything slows, seconds stretch. The world seems to pause between one state of being and another. A baby arrives, still tethered to the mother by that winding, pulsing cord. The body is wet, the lungs are closed, the skin is untested. The brain hums, ready, but waiting. Then it happens, that first gasp, a drawing in, a breath not learned, but remembered, stored in code. In ancient biology, the lungs open like origami. Once dense with fluid, they expand with air. Billions of alveoli stretch for the very first time. Their delicate membranes meet oxygen, and nothing is ever the same again. This first breath is transformation. It marks the shift from a world of water to a world of air. It's from oxygen delivered by placenta to oxygen drawn in by effort, by will, by the diaphragm, to the heart changes too. A hole between chambers, the foramen ovale closes. Blood diverts from fetal detours into newborn roots. The circulation rewires in a matter of heartbeats, and the lungs begin their lifelong rhythm. An inhale, an exhale, a silent agreement to continue. But breath is not the only thing this baby draws in. In that first moment, perhaps still on the mother's chest, perhaps in the hush of a hospital room, something invisible begins. The baby's body is seeded with microbes. Skin touches skin, lips touch breast, eyes blink open to the microbial world. These tiny travelers, bacteria, fungi, archaea, do not invade. They arrive as if expected, as if this meeting was always meant to be. The womb, once thought sterile, is not completely empty of life. But the real microbial inheritance begins at birth. If born vaginally, the baby is coated in the mother's flora from the birth canal, from skin, from milk. If born by cesarean, the seeding is different. More skin than gut, more nurse than mother. Each path is unique. Each journey builds a different landscape, and these microbes are not bystanders. They shape everything. In the lungs, once thought sterile, tiny communities begin to form. The upper airways, the nose, the throat are quickly colonized. They become a gateway between the outside world and the protected spaces within. These microbes train the immune system. They teach it to recognize friend from foe, to react when needed and rest when not. Without this microbial whispering, the immune system flails, overreacts, misfires, attacks itself. But with the right teachers, those early microbes, the system learns nuance. It learns balance. It learns peace. And so the baby grows, breath by breath, microbe by microbe. Every touch adds more. Every kiss, every cuddle, even the air in the room brings new resonance. By the end of the first day, millions of microbes call the infant home. By the end of the first week, billions, and most are welcome in the gut. They form colonies that help digest milk. They break down sugars the baby cannot. They signal cells. They build resilience in the skin. They protect against invaders. They compete for space. They modulate inflammation in the lungs. A gentler frontier, the microbial community, remains. Sparse but influential. It speaks softly to immune cells. It shapes inflammation, calibrates sensitivity. Some researchers call this colonization tolerance. The body allows what it knows is helpful, and it listens. It remembers. Breast milk continues the inheritance. It is not just food. It is communication. It carries antibodies, prebiotics, and live microbes. It feeds the baby and the microbes at once. Each drop is a message. Grow here. Defend this trust. That rest And the baby, though silent, responds. The immune system learns to fold its hands, to pause before it strikes, to negotiate rather than wage war. But sometimes the inheritance falters. If the baby is born too early, or by emergency, or raised without milk, or exposed too soon to antibiotics, the microbial orchestra plays out of tune. Inflammation rises, allergies appear, the immune system stumbles in the dark. Yet even then, the body adapts. It learns again, with time, with care, with new exposures, because life, even at its smallest, wants balance, and the breath continues. The lungs grow, the alveoli multiply, the chest expands. By age 8, most of the lung structure is set millions of tiny pockets ready for a lifetime of work. But even in adulthood, your lungs remember their earliest guests. The microbiome of your airways is shaped by those first weeks, by where you were born, by how you were fed, by who held you, by what you breathe. It is your invisible fingerprint, not fixed, but deeply rooted. And now, as you lie here in a room quiet with memory, your breath is still speaking to the descendants of those early microbes. Each inhale stirs ancient agreements. Each exhale leaves a signature in the air. You are not breathing alone. You never have. So what is breath, if not an inheritance? A ritual passed down not just from parent to child, but from cell to cell, from bacteria to immune system, from air to life. It is more than gas exchange. It is trust. It is history. It is the sound of the body becoming itself. And as your breath slows, let this truth settle. You are a colony, a host, a home. And in that home, millions of tiny lives watch over you as you sleep. They do not ask for thanks. They do not seek control. They are simply their silent companions in the act of staying alive. And in the next chapter, you will follow the breath from the lungs to the bloodstream, tracing oxygen's quiet journey into the very heart of every cell, where mitochondria wait like tiny furnaces, burning air into warmth, into energy, into the very light of thought. Inside you, oxygen floats, not freely, but with purpose, riding the red curves of hemoglobin, passing through vessels that narrow and bend like quiet country roads. Each inhale was only the beginning. Breath didn't stop at the lungs. It transformed, became cargo, bound to red blood cells, hidden in crimson. You breathe in, but is the mitochondria who truly received the gift. Mitochondria. The name sounds almost mythical, but they are real and everywhere. Every cell in your body, except red blood cells, holds them. They are ancient. They are survivors, and they are not entirely yours. Millions of years ago, before humans, before animals, even before multicellular life, a single act of partnership occurred. One cell swallowed another, and instead of being digested, that guest stayed, worked, lived, shared its fire. That guest became the mitochondrion dot. You carry that ancient partnership in every breath, in every heartbeat, in every muscle, twitch, and flicker of thought. The mitochondria take in oxygen, not as a gas, but as a participant, They use it to complete a dance, a delicate chain of chemical steps, called cellular respiration. But do not worry about the chemistry. Let it drift past you like a breeze. Instead, feel this inside you at this very moment. Tiny engines are turning, softly, silently, like embers glowing deep in a cavern. Oxygen enters the mitochondria and meets fuel, glucose, fats, proteins, broken down from your food. Together, they move through the electron transport chain, named too technical for such a poetic process. Imagine a row of lanterns being lit one after another along a hidden corridor. Each step releases energy, controlled, measured, enough to build molecules called ATP, the currency of life. ATP is what lets your muscles contract. It lets your neurons fire. It powers the making of proteins, the pumping of your heart, the blinking of your eyes. Without ATP, there is no action. Without mitochondria, there is no ATP. And without oxygen, the fire cannot burn. But this fire is different. It doesn't scorch. It doesn't smoke. It does not consume you. It warms you at a cellular level. It feeds without frenzy, sustains without haste. This is not the fire of destruction. This is the hearth, the gentle, glowing ember of continued life. And this fire, like all fires, leaves traces, tiny molecules of water, carbon dioxide, sometimes, just sometimes, a spark too bright. These sparks are called free radicals, reactive oxygen, species, byproducts of breathing at the cellular scale. Too many, and they become dangerous. They damage DNA. They rust the body from within. But your cells are wise. They've built guardians, antioxidants, repair systems, proteins that fold and refold. Even the mitochondria know how to protect themselves. They sense when the fire grows too wild. They dampen it. They rest. They repair. Mitochondria are more than engines. They are decision makers. They tell the cell when to grow, when to divide, when to rest, and sometimes when to die. Cellular death is not a failure. It is a grace, a letting go to protect the whole. And when a cell ends its life through programmed death, called apoptosis, it is often the mitochondria that signal it is time. What quiet judgment, what solemn trust we place in these ancient guests. There is something else, a mystery within the mitochondria. They carry their own DNA, tiny loops separate from your chromosomes, passed down only through your mother. Mitochondrial DNA does not mix or recombine like the rest of your genes. It's whispers of pure lineage, a maternal echo going back through time. Every mitochondrion in your body is a descendant of the ones in your mother and her mother and hers. Thousands of generations carried silently through egg cells, into breath and fire. And so you are not just a person breathing. You are a living story of inheritance, oxygen, of ancient symbiosis. You are what happens when breath meets fire and keeps burning just slowly enough to become thought, to become love, to become memory. Now, imagine this, a muscle flexing, like your heart, never pausing, beating even in your dreams. It is the mitochondria who fueled that rhythm. Imagine a brain, billions of neurons, firing in careful harmony. It is the mitochondria who keep the lights on, even as you sleep now. Even as your breath slows, the mitochondria remain awake. They are not distracted. They do not worry. They do not dream. They simply continue, a hum in the dark. There is something sacred about processes that persist without applause. No one thanks the mitochondria. No one feels their fire directly, but without them, the story ends. And that is the truth of many helpers inside you. They are unseen, uncelebrated, and yet they carry you as you drift now. Feel the warmth inside you, not from blankets, but from mitochondria. From breath, turn to fire, turn to energy, turn to stillness. You are not just resting, right? You are regenerating, rebuilding, rebalancing the flames within. And as your body settles into this quiet rhythm, the mitochondria do not stop. They are still there, tending the fires, lighting the lanterns, passing the torch from breath to life. But what of those who are born with faulty mitochondria? Oh, who, with time and age, lose the fire? What happens when the engine sputters, when the cells grow cold, when the body forgets how to glow? The glow fades softly at first, not like a sudden blackout, but more like twilights slowly thickening into night. You do not feel it immediately. You may only notice that rest doesn't restore you like it once did. That strength takes longer to arrive, that your body feels heavy, even when you're still. This is what happens when the mitochondria begin to forget, when the engines grow tired and the fire burns unevenly. Mitochondrial failure is not just a disease. It is the quiet unraveling of life's rhythm at its deepest layer. And because the mitochondria live in almost every cell, their failure does not strike in one place. It spreads from muscle to brain, from nerves to eyes, from fatigue to breathlessness, to memory loss to heart failure. You may have never heard of mitochondrial diseases, but their effects are all around. They often begin in childhood, a baby who cannot hold up their head, a toddler who tires too easily, a child whose eyes twitch involuntarily, whose muscles tremble under their own weight. These children often carry mutations in their mitochondrial DNA, a few misplaced letters in the script of their cellular fire, and though their minds may shine, their bodies flicker. They burn more fuel to do less. They age in strange, internal ways. Mitochondrial disorders are not common, but they are not rare either. And sometimes the symptoms do not appear until adulthood. A woman in her 40s feels sudden weakness in her limbs. Her vision blurs. She forgets names. Doctors search for answers. Thyroid, anemia, multiple sclerosis. But the cause is deeper. It is not in her blood, but in her mitochondria. Or perhaps a young man runs easily one summer, then finds by autumn he cannot climb stairs without panting. Tests show his heart is normal, his lungs are clear, but something has changed. His cells are starving even as he eats, suffocating even as he breathes. This is the puzzle of mitochondrial failure. It is invisible on the surface, but beneath, it is all-consuming. The mitochondria may fail because of inherited mutations in their own DNA or in the nuclear DNA that supports them, but even healthy mitochondria can be worn down by time. Aging itself is often a story of mitochondrial decay. The embers weaken, ATP becomes harder to make, cells repair themselves more slowly, errors accumulate, your skin loses its glow, your muscles lose their strength, your brain loses its clarity. We often call this just getting older. But what if it is really your mitochondrial flame dimming by degrees? And yet, the story is not entirely grim. There are ways we are learning to nourish the fire. Some scientists explore gene therapy, editing or replacing faulty mitochondrial DNA with healthy versions to restore energy from within. Others test mitochondrial transplants, delivering healthy mitochondria to damaged tissue like new sparks, blown into cooling ashdot. There are even experimental drugs designed to boost mitochondrial function, hence ATP production, or reduce the buildup of free radicals before they become a storm. These therapies are still growing, still being tested, but the direction is clear, toward healing from the inside out. Even without high-tech interventions, your daily life affects your mitochondria more than you may know. Fasting, for short periods, gives them rest. It pushes the body to clear out damaged mitochondria and replace them with stronger ones. Exercise, even gentle walking, signals your cells to grow more mitochondria, to prepare for the next effort, to build resilience. Sleep is when they repair. In the stillness of your dreams, they recalibrate, quietly sweeping up the byproducts of your day, and clean air, nutritious food, sunlight in the morning. Each of these is a kindling for the fire. But sometimes, despite everything, the fire wanes. A person with mitochondrial disease may live with chronic fatigue that cannot be explained by depression, nor reversed by willpower. Their muscles may cramp without warning. Their vision may blur not from lenses, but from cells unable to power the eye. Their hearts may beat too slowly or too fast because the electrical system lacks energy. Some lose their hearing. Some lose their balance. Some lose the steady rhythm of their breath. And yet, they live. They laugh. They build lives around the fire they do have. There's a quiet beauty in this endurance. It is not dramatic. It is not viral, but it is deeply human to live with a fire that cannot blaze, yet still find warmth in the embers. This is grace. 2. Notice the fatigue, the dizziness, the breathlessness, and still rise when possible. This is strength, not the strength of heroes in stories, the strength of mitochondria themselves, steady, persistent, resilient. One day, perhaps, we will have better treatments. We may find a way to write flawless mitochondrial DNA, to light the cellular hearths more evenly, more lastingly. Until then, we learn to listen, to notice when our energy wanes, to ask if our cells are tired, to rest without shame, to nourish without fear, to cherish even the smallest sparks. You do not have to blaze to be worthy of warmth. And so, tonight, as your body folds into rest, remember this: your energy is not infinite, but it is beautiful. It comes from an ancient bond, from oxygen and mitochondria, and a fire so quiet you can sleep beside it. As your breath slows, your cells keep glowing. Not with drama, but with duty. Not with brilliance, but with care. And when you wake, they'll still be there, ready to feed you again from breath to flame to life. But what if the balance is even more delicate than mitochondria and oxygen? What if the fire, once disturbed, sets off a deeper chain of imbalances in the body? You rest quietly tonight, but beneath the stillness, something pulses. Not the beat of your heart, nor the breath in your lungs, but a quieter conversation whispers, carried between your cells. A flare, a signal, a shift in the air of your bloodstream. This is inflammation, not a wound, not a fever, not an infection you can name, but the language your body uses when it believes something is wrong. And, like all languages, it can be poetic, nuanced, or misheard. Tonight, we explore how that language begins deep in the mitochondria, how the fire in your cells can spark not just energy, but alarm. Imagine a spark drifting from a campfire. If it lands in the right place, it fades. If it lands in the wrong place, it ignites a flood of flame. Your mitochondria are careful with sparks. They work with oxygen, and oxygen is flammable. When the fire burns cleanly, you get energy. When it burns unevenly, you get signals, fragments, reactive oxygen species, pieces of broken code. These fragments are not just waste, they're messages, and if enough of them appear, your body interprets them as danger. Inflammation begins not in the bloodstream, but in the mitochondria. A whisper becomes a shout. Your immune cells respond. They leave their resting state, travel toward the signal, and prepare for battle. They don't ask questions. They act. They release cytokines, molecular messengers that amplify the response. Other cells join in. Blood vessels dilate. Barriers tighten. Heat rises. Everything focuses on the area where the spark fell. This is how your body protects you. This is how it heals. But sometimes the spark is a mistake. A misfired message. Chondrion sending distress, not because of invaders, but because it is tired, broken, old. The immune system cannot always tell the difference. It only hears the alarm. This is the quiet origin of many modern illnesses. Chronic inflammation doesn't always begin with trauma. Sometimes it begins with mitochondria that can no longer keep the fire clean. They leak fragments. They release mitochondrial DNA, which looks suspiciously like bacterial DNA to the immune system. After all, mitochondria were once bacteria. Long ago, the body reacts. It treats the fragments as invaders. It floods the system with immune signals, and so the fire that once gave life now calls down the storm. You may feel this as fatigue, or joint pain, or brain fog that settles like smoke. You may be diagnosed with autoimmune conditions, lupus, rheumatoid arthritis, multiple sclerosis. You may be told it's inflammation, but not know why it began. Sometimes, the beginning is in the mitochondria. They do not just provide energy, they guide the immune system, okay? Tell it when to stay calm and when to rise. When they lose that ability, the immune system begins to guess. And sometimes it guesses wrong. In neurodegenerative diseases like Parkinson's or Alzheimer's, the fire and the flood dance together. Aging mitochondria release too many reactive oxygen species. Neurons respond by triggering inflammation. Microglia, the immune cells of the brain, remain on high alert. They clean up, but in doing so, they release more fire, and the cycle continues. Flame begets flood. Flood worsens the flame. Even in depression, stance appears. Studies show that people with major depressive disorder often have signs of both mitochondrial dysfunction and systemic inflammation. Their energy wanes. Their immune system activates. They feel tired, foggy, and low, not just in mood, but in cellular reality. And yet, the body tries to regulate. It's not reckless. There are circuits of balance. Inflammasomes, molecular complexes inside cells, are like switches. They detect mitochondrial distress. They decide when to raise the alarm. If the signals are small, the inflammasome stays quiet. The signals grow. It tells the cell to release cytokines, to prepare for defense. But sometimes these switches break, or they're too sensitive, or they stay on too long. Inflammasomes have been linked to diabetes, heart disease, even aging itself, when the fire no longer respects its boundary. The flood becomes chronic. What can you do then? How do you cool a fire that you cannot see? First, you rest. Sleep is when the inflammasomes quiet down and reactive oxygen species are cleared. When your cells clean house, deep, unbroken sleep may be one of the best anti-inflammatory tools your body has ever evolved. Second, you move. Exercise burns fuel, yes, but it also teaches the mitochondria to burn cleanly. It produces mild stress that strengthens them. It calms the immune system over time. Even walking is enough. Third, you nourish. Not just food, but light. Sunlight sets your circadian rhythm. And circadian rhythm governs mitochondrial repair, immune modulation, and the inflammatory cycle. A morning walk is not just good for your mind. It is a message to your cells. We are safe. You may rest. Then there's the gut. The microbes in your intestines communicate with your mitochondria. They produce short-chain fatty acids that signal anti-inflammatory pathways. They influence which genes are turned on in both immune and mitochondrial networks. A dysbiotic gut, one out of balance, can lead to systemic inflammation and, through it, to mitochondrial exhaustion. Your inner ecosystem speaks more languages than you know, and all of them can trigger or calm the flood. Some scientists now believe that the hallmark of many age-related diseases isn't the loss of energy, but the chronic misfire of inflammation. Mitochondria play both sides. They feed your cells, and they signal when to defend. If they break, both sides suffer. So aging, in this view, is not just rust. It is flame and flood. Cells that once worked together now pull in different directions. Some try to repair. Others try to destroy. All are acting on information from mitochondria. It is the story of a misread message echoing through time. But there is hope in the silence. You can influence this story with habits so gentle they almost feel like stillness. Moment of breath work calms the vagus nerve, lowers cytokine expression, quiets the inflammasome. A glass of water flushes toxins, cools the body, stores pH balance. A small kindness with wide effects. A soft belly laugh releases endorphins, improves mitochondrial output, reduces stress-induced immune activation. Even listening too slow, meditative music, or the wind through leaves can shift your nervous system toward rest. And in rest, the mitochondria heal. The fire glows. Without burning, the flood subsides. So tonight, as you lie in the dark, remember, you are not just resting your mind. You are recalibrating an ancient conversation inside you. Cells decide whether to fight or to soothe. And you, through breath, through stillness, through care, have a say in that decision. You are not at the mercy of invisible alarms. Are the balance point between fire and flood. A moment of calm can change the chemistry of your blood. A night of sleep can heal the whispering flame before it shouts. You do not need to fix it all. You only need to soften and let the healing begin. And yet, what happens when healing isn't enough? When the energy fades, not from disease, but from time. In the final chapter, we will return to the quiet center of your cells, to the mitochondrial twilight, and ask what it means to live with grace, even as the fire dims.